Okay, you worthless sacks of crap, listen up. We have an important mission for you, and you better not screw it up. This information we need will destroy the world if it falls into the wrong hands, so we need to get to it first. Our high-value target? Professor Walker. His research and knowledge on the world is valuable to our operation. Your mission? Subdue the target. Do not kill him. Bring him here. Michael, extract the information.
Yes, sir.
Once done, bring the information to me. All clear?
Sir, yes, sir.
Alright, we roll out in 1300 hours.
Great. Don't move, sorry, people. Get up. Get moving. Stay quiet. Remove his bag.
Where am I?
Derek, you're free to go.
Where am I?
You'll find out soon enough. If you don't cooperate with us, you will end up like him, dead. Now we need information. Where is it?
You think you're the only group that's ever come to me for this kind of crap, threatening me for calculus information? You don't scare me.
You just don't listen, do you? Shoot him his arm. Now, listen to us. Cooperate. We're your friends. We know that calculus is important to the world. If it falls into the wrong hands, the world's doomed. The product rule, the quotient rule, derivatives, all that's important. We need it. We need you to teach it to us. Are you going to listen? Are you going to cooperate?
Alright, I'll do what you want. But first, you gotta untie me.
Oh yeah, you do need to write. So now, get you some paper. Now show it to us.
Alright, so do you know what a derivative is?
Yeah, it's the instantaneous rate of change at a point. That's what it is.
Alright, so this is what the product rule does. It has to do with derivatives. The product rule is where you have two functions that you're multiplying. Alright, the basic definition of the product rule is this. It's the derivative of your first value times your second value plus your first value times the derivative of your second value. Apply this to something such as, x squared times e to the x. So you take the derivative of the first function, which is 2x, times the second value, which is e to the x, plus the first value, x squared, times e to the x, which is the derivative of e to the x, is just e to the x.
So that's the derivative of x squared e to the x.
Yes.
And you have to use the product rule to do that.
Yes, and I'm going to explain to you real quick why you have to use that. So, say for example you have something like x to the 11th. Well, normally you could just say, 11x to the 10th. That would be a normal derivative. But because we're talking about two functions, you could do something different, like x to the 5th times x to the 6th, which is technically the same thing, but if you take the derivatives of that, you get 5x to the 4th times 6x to the 5th, and then that ends up getting 30x to the 9th, which does not equal this at all.
I see. So it's very important.
Yeah. I'm going to explain the quotient rule. The definition of this product is pretty much, it's similar to the product rule, but there's an extra twist into it. It's the derivative of the first product times the second minus the first product times the derivative of the second product, and then it's over the second product squared.
Now what's an example with that one?
Well, let's use a similar example with x squared and e to the x, except this time we're going to divide. And the derivative of this, you just do 2x e to the x minus u is x squared. And then the derivative of e to the x is e to the x. And then your v value would be e to the x squared, which e to the x squared is just e to the 2x.
And that's all.
Yep, that's pretty much it. Alright, that's all I know. Can I go now, please?
Sure, you can go. Grant, put the bag back on his head and show him the door. Told you calculus is important, and we can't have you telling everyone that we got your information. So goodbye.
What? No, no, no!